thank you so much for being here today. I'm going to kick things off and talk about some of the trends that I'm seeing. And I wanted to start with these because I think, so my name's Melody, I'll introduce myself, because I think they influence how we think about developing software. And the challenges that we have today in terms of developing software are different than we had, 15 years ago, 10 years ago, 5 years ago, last year. So just some things that are top of mind for me right now. So I think you heard earlier in the morning about developing on multiple devices. This is the world that we live in, right? The majority of folks in the US have smartphones. We need to be thinking about how we write software to work effectively on tablets, on laptops, on mobile phones, and wearable devices. So that is influencing the type of platform that we need to be thinking about when we're doing development. Clearly, there's an expectation that you should be able to be connected to systems anytime, anywhere. And as John mentioned, this whole idea around SLOs and SLAs and thinking about reliability and the terms of reliability that we, as system providers, are committing to for our users and for our customers. Speed, at Google specifically, we think a lot about speed and performance, about getting our users the fastest results possible, and the highest quality results. And thinking about that level of processing that we need to do influences a lot of how we think about developing the systems that we write. And then I think part of what I'm excited to talk about today is the collaboration that can happen and how we can take the things that we're developing in-house and mix them with tools that are being developed in the marketplace, like open source systems. So those are some of the things that I'm seeing that are influencing how I think about software development and the tools and frameworks and environments that we need to manage as part of software development. So just to share a couple stories about Google. So having been at Google for almost 10 years now, when I joined, I worked at startups and other software development houses, and it was not uncommon for me to have a 12-hour build turnaround cycle. And that was just kind of the expectation. Working at Google, we've invested significant amount in our build, test, and source control management systems. And the reason why I think this is very interesting is that engineers can do things when they don't have to think about a 12-hour lag time. So our build system, for example, supports multiple languages, and it provides, second response in terms of what's breaking and what's going to work. On the test system side, we test with every repository submit. We have this interesting thing that we call pre-submit, where you can find out about breakages ahead of time. And again, it's not just about coding and making sure that the software compiles, it's about testing it. And when engineers don't have to worry about their code being tested, it leads to interesting things happening. A higher tolerance of taking risks and failing, because they know that that safety net is there. And as John mentioned, our source control system is very open. Any engineer pretty much can look at any part of the code base. And I think that level of openness has led to us investing in common libraries, common frameworks, and a culture in which when engineers find a defect in a library that they're dependent upon, they will just go ahead and fix it and submit the fix to the engineering team, even if they're not on that team. So, talked a little bit about the speed and scale, but because we have these systems in place, we're able to do things like, run 800,000 builds in a day, and run 75 million test cases, and support, 25,000 change lists in a day. And that level of iteration, I think, has been a key differentiator for us in terms of getting code out the door and enabling our engineers to be not just fast and develop safely, but also happy in the systems that they're using because they're not waiting. They're able to focus on code and getting features out the door.
So I want to first, my name is Rajiv Bharadwaj. I come from HP. I run R&D at HP. I first want to talk about Openstack. There are some perceptions, misperceptions about it. I kind of want to walk through that. A variety of people, there's been a lot of talk about Openstack recently, right? So positive, negative. So in terms of history, it's 4 years old. It's not a new project. It's not an old project either. There are right now over 2,000 developers working on OpenStack, and pretty much every company is represented in OpenStack. And OpenStack, again, I first went to the conference about 3 years ago, and a clean shirt there, by the way, is being overdressed. So this is like massively overdressed. So you go there, and there are a bunch of people who do presentations. There are blueprints. And when you see that, you don't think that, hey, is there something useful that's going to come out of it? And, you don't have that feeling. But things do happen. Do things happen fast enough? Maybe, maybe not. In some areas, some of the services are pretty mature. Some others are not mature. But the reason why these large companies have continued to invest in something like OpenStack, which is, by the way, the largest open source project right now, is because of what happened to Linux and GNU compilers, right? If you see GCC and Linux, they've beaten everything else. There is no other operating system as popular as Linux. It took its time. I still remember I worked on the kernel on Solaris, and we always poo-pooed the stuff in Linux, but it was good enough, and over time it got better. And that's the basic belief system which allows everybody to work on it, and at some level, almost all closed source systems would have to evolve towards it. Does it solve the greatest Paxos algorithm at that point in time? Probably not. Does it actually give you 5 nines of availability? Probably not. But it'll get there. And it'll get there because of the system. It's a religion. It's a belief system that comes with it. So in its simplest form, OpenStack is actually not a single system. It's an abstraction layer. It presents itself a variety of services. There are about 15 or so projects, which are called core projects. And these core projects essentially present APIs, REST APIs, and command lines that you can execute. And over time, they have incubated projects that come in. And each one of these projects are run by a sort of a meritocracy system where you are elected as a PTL. Every time you go in for a vote, people vote for you. And people who vote for you are core committers. And these people continue working on it. And then you actually do work to become a core committer. So you kind of go up the chain of people, and then over time, these people actually give you feedback, and you get more and more power within the system. And OpenStack also has its own board, has its own technical committee, and they determine the direction of how people are going to do work. So it's sort of like, in some ways, the greatest democracy, right, in terms of coding. In Linux, for example, Linus has got a lot of power. In OpenStack, there's no single person who wields so much power that I'm going to control the direction of where OpenStack goes, which is kind of nice, but also it leads to some level of chaos, right? It's a new thing. We are learning over time, and we are getting better at it. OK, so the other thing is, the amount of churn that happens in OpenStack is tremendous. I mean, as we speak, there are people checking in code. And there's lots of codes, lots of mistakes people make, right? And the language of choice is Python, and you can make mistakes in Python fairly easily. It's a dynamically typed language. So how do we actually solve this problem? So we have our own CI/CD system. It's one of the largest CI/CD systems. So every check-in or a patch merge basically gets reviewed by a bunch of people, and it's all automatic through a Gerrit system. And then it gets actually checked. There is a batch job that runs periodically that goes and tests it, and it runs an actual test job, and the testing system actually gets a vote, and it tells you whether your code actually passes the test or not, and it's all dynamic. And once you get like +2 from the reviewer and the testing system, then it gets automatically merged at that point. So the so-called +2, the plus system, is one of the things. What you don't want is a -2 on the code base, because your stature for OpenStack actually drops because you got a -2. So you kind of solicit enough feedback from other people to make sure that you get it. So the CI/CD system, by the way, within HP, we run the CI/CD system for OpenStack. So we have a lot of experience in that. And we use the same CI/CD systems for our own products. So we have a lot of experience in that. The other points, OpenStack does have its own set of problems, right? So for example, HA is slowly getting there. So there are some issues, but we're getting there. DR is one more. Updates, for example, how do you actually make changes fast enough? How do you, when change happens so quickly, there are 2 releases per year, and there's quite a bit of churn per release per year. How do you update the systems? So the update system is a problem. But that's where HP, because we have both a public cloud and private cloud based on OpenStack, that's where we come in and we have some value, we can help out. OpenStack also has a culture, it's a religion, right? So the religion has got people, there's a lot of people who are extremely good programmers in, say, Java or C, actually may not do very well in OpenStack because they don't like this meritocracy. They don't want to kind of go up the chain of trying to get street creds to do it. It's a bit of a pain, right? Then the other thing is it's language. It's Python or nothing, right? I mean, the Gerrit system is based on Java, and of course, RabbitMQ is Erlang-based, but generally it's Python-based, so you may not like the language. The other thing is you can't critique much. I mean, it's sort of like, if you don't like something, fix it. It's as simple as that, right? So you're sitting back and saying, "Ooh, it doesn't work. It just doesn't work here." If you don't like it in OpenStack, you can get in, suggest something, and just fix it. And it doesn't matter who you are, which part of the world you are from. And it's completely democratic. One of the PTLs, for example, is in Saratov, Russia. He's 23 years old. It turns out that he's absolutely brilliant. But you could not have found a guy in Saratov, Russia, to actually be the PTL for Sahara in any other project except something like OpenStack. So I mean, it's just a different way of programming. The other thing about OpenStack is it's kind of cool. My son is 19 years old. He would not work on infrastructure programming for sure, but he will work on OpenStack. It's kind of brought that coolness, and if you go to a summit, by the way, the next summit is in Paris, so it behooves you guys to come here. Okay, so it's amazing what you see. There's a lot of energy. Fairly young people show up there, and we want to actually do this. So that's my thing, and HP has a set of products that we release in terms of public cloud, private cloud, and managed cloud based on this. Thank you.
So I'm Tim Kimmett, and I work for Walmart Global E-commerce. I own the team that we call Platform. And what I wanted to talk about is how we deal with application lifecycle management. And this is a huge passion for me. A lot of people that know me in this room from ex-eBay days, I was a developer for most of my life. And a lot of the things on this slide were pet peeves of mine that were really hard when I was a developer to get things done really fast. And so we talk a lot about agile, about you write it, you own it, giving developers the tools that they need to be successful to really do this thing that we call agile. And really, if you don't have these kind of tools, then you're really not empowering developers to own it end to end. And so what I'm going to talk about is the tool that we have that's called OneOps. And some call it Platform as a Service. We call it Application Lifecycle Management. They're all overloaded terms, so don't go to Wikipedia and look it up and say that's what I do. But I'm going to talk about a couple of core constructs that we have that really enable developers to own it. And so the first one is an account. It's simple. You get an account when you start Walmart into this tool. But the important thing is that once you have that account, given who you are, you have access to things. If you're a cloud administrator, you have a lot more access than others do. If you're a developer, you have access to create environments, you have access to different clouds and stuff like that. And right now we have 14 of those. And so the next phase is design. And this is a really important phase because it's really codifying your dependencies on infrastructure. And so these were typical meetings that I would have with operations and other folks to talk about, hey, I need this port mapping over here. I need this database over here. Those need to connect to each other and all these things. And that was specified in this design. But now we can check that in, and it's repeatable. transition is taking that design and putting it into an operational environment. And that's where you specify the auto scale capabilities and all those things and get it running into an operational environment. And then finally, once you're in operations, you want to manage it, you want to monitor it, and you want to monitor the health of the application. And so this is how we really think about application lifecycle management at Walmart.
Hi, good morning. My name is Greg Wyant. I'm the VP of Engineering at Glue Networks. Been there the last 2 years. Part of that, I had 23 years at Intel as the IT CTO, and I designed some of the early chipsets that were the foundation of the PC industry. I date myself now, right? 386, 46, anyone? Remember those? All right. So what we do at Glue Networks is we actually design cloud-based software that allows you to define the architecture for your wide area network in the cloud, and then do automated provisioning of the endpoint devices in under 10 minutes, regardless of where they sit on the planet. And so it's the ability to turn up and provision devices very, very quickly and then do ongoing management of that. And so getting software in place, first of all, from an architecture perspective, when you're doing design, is all about understanding exactly what your endpoint devices are going to be, bridging that gap between the DevOps world and the networking engineering world, and how people think about the traditional methods of manual provisioning of routers, for example, through good old CLI. And as more and more devices are starting to add programmatic interfaces on it, building that intermediary orchestration software to sit in the cloud to in turn talk to those devices and to bring them up. From there, we move to deployment, and I've heard this, this morning as well as yesterday. Agile environments and getting the engineers to think in that way, absolutely the way to go. 2-week sprints is what we operate to. We have integrated design and test functions within Glue Networks. And I'm not only using the cloud as a place to hold the software that I am producing, but I'm also using the cloud as a way to actively test the capabilities. So my ability to spin up 1,000 virtual routers in an Amazon Web Services or in Google or in Rackspace or in Azure, and then go and provision those things on the fly, bring them up, tear them down, do different things around scalability testing, allows us to test at a level that in the past would require physical hardware and a massive capital investment by a company. So I think it's critical to understand not only what you're designing for in terms of the standard you're using in-house, but what are you designing to in terms of what are you going to interoperate and interact with as you're doing your tests for ultimately deployment. As we move into things like maintain, that's keeping the software consistent. We talked about this set of standards that are being used in place from a release production perspective. Internally we're using Jenkins, standards that we're following, obviously Linux-based because we know that's where the world has gone. AngularJS for UI, responsive web design, looking at targeting endpoint devices ultimately, so I can be sitting on my tablet, flying on a United Airlines flight across the water and be provisioning a network at the same time in real time. Those are the kinds of capabilities that we're really trying to get to, is let's get out of that passive, we were talking earlier in the keynote from Google talking data center of this idea of weeks to provision a capability. Now I want to be able to do it in a matter of seconds or minutes, and likewise have the software comprehend the capacity and the amount of compute required and storage required for the given solution that it's supporting so that it can dynamically scale itself and understands how to spawn its own VMs, spawn its own deployment engine so it can work at scale relative to the solution that we're trying to put in place. And then finally, optimize, looking how the software performs. There's a combination of open source tools that we make use of. There's also internal tools that we've created based on standards, Eclipse, et cetera, that will do real-time monitoring of the solution as it operates in the cloud itself. So literally to the point where it'll do trap and debug on individual points and tell us exactly what happened through an individual deployment so that we can rapidly make a change. And literally we're fixing things in a matter of minutes and seconds versus hours and days in the past. So I think, again, as you think of this virtuous circle in development, moving yourself from design to deploy to maintain to ultimately optimize, feeding that back into your organization and rewarding your organization for the quality and the code that they're putting forth is critical for deployment.
So let me start with the problem statement. So many enterprise companies, and actually many of you raised your hands when you said you work for enterprise company that actually doesn't build software for revenue, but increasingly relies on software for business, right? So we have some common challenges. One of them is we have heterogeneity of environments, anywhere from shrink-wrapped software to custom-developed software, which was circa 1980s, 1990s, and then the latest software that is cloud-wrapped, scaled-out infrastructure. So you have this heterogeneity. There is not a software-defined SDN we didn't like. There is not a version control system we didn't love. There is not a compute platform we didn't like. So traditionally, when you walk into that kind of a shop, the complexity is not because of the scale. The complexity is often because of the uniqueness of infrastructure. Give you a classic example, in a shrink-wrapped software world, I would have a discussion with the business partner, and the business partner would say, well, which server do I own? And it was actually an owning discussion. And John talked about that, right? How do you move from that to a declarative statement about what is it that you're really trying to drive? And building the trust of moving away from thinking of commodity services as things that you own to what kind of a contract you have between infrastructure and software development. So our focus at Gap has been, how do we make the job of a software developer easy, right? And so we have made this transition from traditionally a shrink-wrapped software company to a much more agile software development company. And with that comes a set of challenges, because we still have that shrink-wrapped software still there, right? So one option that we have already built out is the common substrata. So what is the common substrata between all these three types of heterogeneous software that we can make as services available to our customers? So that would be common monitoring, let's say Nagios, common logging, chef-based cookbooks, which help you automate provisioning. You look at Graphite and Kafka for logging and metrics and messaging. So there are ways we can make even the shrink-wrapped software a little bit more easier to manage and monitor and deliver against. We also moved most of our shrink-wrapped software to common commodity-based platforms and open source systems. So that was a big undertaking, but really, again, with the mentality of, I want to simplify what I'm dealing with in my infrastructure. Now, if you go beyond that, what you're really looking at then is, from a Gen 2, Gen 3 world, how do I make my software release management that much easier? Moving from we traditionally today have global releases, and often what you look at most companies is you are as slow as the slowest point in the chain.